that would be standard time or clock time. All right, continuing on to review the different types of formulas. So I don't like to teach formulas. Ms. Shante and I shy away from teaching formulas. The book addresses it. There may be questions regarding it either on your test or in your quiz, so I'll address it. So there is a formula. So this is primarily when they order a single medication. It's in an injectable form, and most often it's easiest when you're using 1 milliliter dose. The basic formula is D over H equals X. So D is the desired dose. H is the concentration we have on hand. And it's implied that it's over 1. So that's why we don't have any additional information. So using this, finding the desired dose, D, we would have to be given by the physician, determine the concentration on hand. So in this case, that would be our 40, and it's over 1 milliliter. So it would be whatever the order is divided by the 40 gives us our answer. So, for example, if the order is for 120 milligrams. Our desire is 120. What we have, that should say 40. So that should be 3 milligrams. I have no idea where that 30 came from. So anyways, doing it properly, 120 divided by 40 is equal to 3 milliliters. This formula just forgets the units until the end. So again, use this one with caution. We want to use units because that helps us make sure that we're not making an error. Now, the other piece of this basic formula is what we call the D over H times Q formula. And then this is when the volume is something other than 1 milliliter. In both these formulas, D is a desired dose and H is on hand. In this one, Q is the volume, the concentration of the drug is. So we don't have the Q in the previous one because it is 1. So 1 times 1 is 1. So in this case, the order is for 300 milligrams of Fliacet. The drug on hand has a concentration of 150 milligrams per 2 milliliters. So our desire is 300, what we have is 150, and how it comes is 2 milliliters. So D over H times Q is the 300 divided by the 150 times the 2. 300 divided by 150 is 2, so 2 times 2 tells us we need 4 milliliters. Basically, this also will replicate a ratio and proportion calculation. Now, the ratio and proportion method is best used in sterile compounding scenarios that meet the following criteria. The drug stock is already in a liquid, injectable form, doesn't need to be reconstituted, and even if it does, once we're given the amount of reconstitution, we can use that concentration. The stock drug is in a powdered form, or the liquid or powder requires completion of additional steps. So this is one of the methods you should have learned in pharmacy math. It also was reviewed in the pre-course assessment. The left side of the equation is the concentration of the drug we have on hand. So always start with what you know on the left. That would be our concentration of the drug. So we use that as our setup. We want the right side to be what we need. So this is what we have, and this is what we want. So if we have milligrams on top, over here, we want milligrams on top over here. Now, this is like a balance beam. We have an equal sign. So whatever's on top on one side has to match on the other so that they're equal. So that tells us that if we have milliliters over here, then our answer will be in milliliters. So then we would go through this problem and doing our calculations and isolating x. X is equal to 1,500 milligrams times 10 mLs divided by 500 milligrams. Our milligrams cancel, leaving us with our milliliters. Get rid of a couple of zeros there. So I have 150 divided by 5, which makes 30 milliliters. So, ratio proportion. Now we have this one. Let's have you solve for the amount that we need. Okay, so now I'm going to walk you through it to check your answer. So first we're going to set up the ratio, and we're going to determine what we have that we are starting with. So this one is ciprofloxacin, 400 milligrams. A single dose vial contains 40 milliliters. So I have to read this information. So I have 400 milligrams and 40 milliliters. Then I have to decide, okay, now I know what I want. Oops, that should be milligrams. I need to see my order is for 200. Now you know that I'm only concerned with the drug. I don't want to worry about my base solution yet. All right, so I set up my ratio. Now I'm going to do my cross multiplication. So X is equal to 200 milligrams times 40 milliliters divided by 400 milligrams. Do my cancel, get rid of some zeros. So then I determine my division, and my resulting answer will be 20 milliliters. All right, how'd you do? The next method is dimensional analysis. So this is calculation by cancelization. I believe the majority of you practice this with Miss Ashante, and this is kind of your go-to. So that's all well and good. And like I said before, stick with what you know. So generally with this, we determine the answer first, so what we need, and we let that set up our problem. So because we're trying to find volume, generally what we're trying to find is milliliters. Determine the volume of the drug to prepare the product. You may need to do one or more conversions between different units of measure. Put the unknown quantity you want to define on the left side of the equation, and then follow by the equal sign. And start with the unit that you want to help set up that problem. So